welcome back to The Explainer. Today we're diving into what is honestly the absolute most critical business imperative of our time right now, deploying AI safely and reliably. Look, we aren't just talking about spinning up some cool basic chatbot. We're talking about building robust, secure, and incredibly fair systems that we can actually trust with sensitive data and massive, high-stakes decisions. So let's break down the ultimate blueprint for trustworthy AI.
Here's our roadmap for today. We'll be walking through the need for trustworthy AI, the 4 pillars of AI trust, an end-to-end practice framework, continuous evaluation, and finally, global standards and tools.
Let's kick things off with Section 1, the need for trustworthy AI.
Okay, so AI is no longer just a fun little tech experiment. It's core enterprise infrastructure now, and it's driven by 4 totally non-negotiable factors. First up, reliability and performance. You've got to prevent costly model drift. Second, safety and trust. We have to prevent toxic outputs because, let's be real, those can literally destroy a brand overnight. Third is strict risk and compliance with emerging laws like the EU AI Act. And fourth is business impact, because doing this right actually creates a massive competitive advantage. The biggest takeaway here boils down to a really simple equation. Trustworthy AI has to be accurate, plus reliable, plus safe, plus secure, and, this is the big one, aligned with business and human values. You can't just pick 2 or 3 of these. Driving true value at scale requires checking every single box all at the same time.
Right out of the gate, organizations face a huge strategic dilemma. On one hand, you've got proprietary or hosted models like OpenAI's ChatGPT or Google's Gemini. They are unbelievably powerful, but you have to send your data out. On the flip side, open source or self-hosted models like Meta's Llama give you complete control and privacy. But, you also inherit this massive infrastructure and maintenance burden. And honestly, this one choice kind of dictates everything that follows.
Moving right along to Section 2, the 4 pillars of AI trust.
Pillar A is model validation. The main goal here is verifying that the model is fit for purpose, robust, and most importantly, generalizes to unseen data. It's about confirming the model actually works in the wild, not just in some pristine, controlled lab. We rigorously check data quality, accuracy, and enforce fairness so the AI operates reliably, without any inadvertent discrimination in high-stakes areas like HR or lending.
Pillar B is benchmarking. This means comparing models objectively against industry standards and peers. We aren't just guessing if a model is good. We use rigorous, established benchmarks like MLLU for general knowledge or GSM-8K for math, or even custom enterprise-specific tasks to measure performance with hard, undeniable data.
Then there's Pillar C, which is AI safety. This ensures the model behaves safely, actually aligns with human intent, and avoids causing harm. We're zeroing in on harmlessness, meaning zero toxic or illegal content, truthfulness to stop those infamous AI hallucinations, robustness against deliberate misuse, and strict adherence to its instructions.
And Pillar D is securing AI systems, protecting your data and infrastructure from threats and unauthorized access. Think of this as your defensive wall. It covers data privacy, protecting the model from malicious training data extraction, blocking dangerous prompt injections, and keeping the core infrastructure locked down tight.
So to actually operationalize these pillars, we have to decode all these abstract concepts into hard math. Toxicity rate measures the exact percentage of harmful outputs. The jailbreak success rate reveals exactly how easily a malicious user can bypass your guardrails. And perhaps the most fascinating one is expected calibration error, or ECE. It measures the gap between the model's accuracy and its confidence. Say you ask an AI a complex legal question. Well, ECE tells you if the AI is genuinely certain or if it's just taking a wild, hallucinated guess.
All right, Section 3, the end-to-end practice framework. The initial phase is all about preparation and selection. First things first, define your exact use case, success metrics, and risk appetite. Next, you have to meticulously govern your data, handling all the sourcing and privacy, because you simply cannot train a reliable model on garbage data. Then you build or select your proprietary or open source model, and finally, validate it with some initial tests to see if you can accept it or if you need to iterate.
Then we move into deployment and beyond. We benchmark our chosen model against baselines. We run incredibly rigorous safety checks, literally red teaming our own model to expose its vulnerabilities. After that, we lock down our security controls, deploy the model with strict guardrails and logging, and finally set up continuous monitoring to catch any data drift as the real world starts interacting with the system.
Which brings us right to Section 4, continuous evaluation and metrics. When you zoom out and look at the macro ecosystem of trustworthy AI, you've really got to pay close attention to the continuous cycle going on. Real-world production data is constantly flowing into evaluators, generating alerts on a dashboard, which then feeds directly back into retraining and improving the model. It's truly a living, breathing system. You don't just build an AI, you raise it. To manage that crazy continuous loop, your key metrics dashboard needs to track the system's vital signs every single day. You're monitoring performance through F1 scores, calibration via ECE, safety through toxicity rates, security through jailbreak success, and maintenance by keeping a very close eye on concept drift. Tracking these vitals is how you catch anomalies way before they turn into full-blown operational disasters.
Look, if you remember literally nothing else from today, let it be this 5-step mantra for operating AI. Validate rigorously, benchmark objectively, enforce safety, secure relentlessly, and monitor continuously.
Finally, we've got Section 5, Global Standards and Tools.
The really great news here, you don't have to reinvent the wheel or invent the rules from scratch. Lean heavily on established global frameworks, like the NIST AI Risk Management Framework, the ISO 42001 system, and the OWASP Top 10 for LLMs. By utilizing model cards and definitely keeping a human in the loop for high-risk decisions, you ensure your compliance holds up to even the most severe scrutiny.
And to actually put those high-level standards into practice, there is an entire ecosystem of specialized tools ready to deploy today. You've got robust evaluators like Hugging Face and Ragus, targeted safety tools like LlamaGuard, and specialized security platforms like PromptFu and Lakera. Paired with standard infrastructure like Kubernetes and monitoring from Arise or Langfu, it truly takes a specialized village to keep AI trustworthy.
Which leaves us with one final kind of wild thought. If AI models continuously evolve, learning and mutating with new data at absolute lightning speed, can our safety measures ever truly catch up? It's a fascinating, ongoing cat-and-mouse game. Building trustworthy AI is never a final destination. It's just a continuous journey of adaptation and structured learning. Thanks for joining me for this explainer, and keep questioning the systems that shape our world.